random sample of 285 voters registered in the state of New York showed that 130 voted in the last general election. A random sample of 220 registered voters in the state of New Jersey showed that 124 voted in the most recent general election. Do these data indicate that the population proportion of voter turnout in the New Jersey is higher than the New York? Use a 5% significant level. So seems like we are doing a hypothesis test. So 5-step basic, null and alternative, I assume is 1. 2 is the test statistics, which we're going to investigate is claim is valid or not, and I'm going to do a p-value approach and decision, and then of course the conclusion. All right, let's take a look here. What is given in this problem? Okay. So in this problem, a random sample of 285. So we are going to actually identify all of this. So 285, that is my N1. That is my N1. And then of course, this is a fixed trial. Fixed trial will result in 130 success. So 130 success. So I'm going to put this is my X1. Or I can have my R1. Some book uses R1, but this is a success we are looking for. This is a fixed trial. 285 out of 285, 130 success. So that's the X. As sometimes it can be just binomial, trial. Then the second one, a random sample of 220 fixed trial. 220 fixed trial. So I'm going to have this as the N2, and that will result into 124. So that is my X2. That's my X2. What else is given? The alpha is given as a 0.05%. So alpha is given. This is the alpha. Okay, so we're going to have to declare the null hypothesis. So obviously this is going to be two proportion. This is a New York population, so I'm going to assume my New York. So I'm going to actually underline it here. This is going to be a New York, and I'm going to say this is my phi1, and the New Jersey, and the next one is down here is in New Jersey. So that's my phi2. So that's my phi2. So I'm assuming they are equal. Phi1 and phi2 are equal. Population proportion 1 equal to population proportion 2. That is going to be always my null hypothesis. Okay, let's declare the null hypothesis. So H sub 0 colon population proportion 1 equal to population proportion 2, or I can just rewrite it with a little bit of algebra, get everything in one side. Phi 1 population proportion 1 minus population proportion 2 equal to 0. That's always true. That is null hypothesis. Alternative hypothesis is going to be H sub 0 colon. That is the big information here. We have a three option. Either is a left tail, a right tail, or two tails. So how do we come up with that? We're going to read it. Do these data indicate that the population proportion of voter turnout in New Jersey is higher than New York? Okay, here you go. New Jersey. So what I label New Jersey? New Jersey I label it phi2. So that is my phi2 here. So that is my phi2. Okay, let's do phi2. And New York, I said that is my phi1. So they said higher. Okay, that's the higher. So higher than. So phi2 is greater than phi1. Well, since I have phi1 at the beginning, so I'm going to use my phi1. So if I use phi1, I can rewrite this as I can just rewrite it phi1 less than phi2. And that would be my nice statement here. So that becomes a left tail, as you see. Even though question is saying higher, but this becomes a left tail. I hope we understand this inequality here. Again, I can write down phi2 proportion 2 greater than proportion 1 because New Jersey is greater than New York. So that's the alternative hypothesis. So I'm going to write down phi1 less than phi2. So that's my alternative hypothesis. So it's going to be proportion 1 less than proportion 2. And the same way I can do phi1 minus phi2 less than 0. Okay, that's my null and alternative hypothesis. Now test statistics. Since I already see this is two proportion test, of course we're going to do two proportion z test. So because sample size is way bigger, and it's central limit theorem says if sample size is so big and n times p is really greater than or equal to 5, of course this is z statistics. So what is the formula for z statistics? So z is equal to sample proportion 1 minus, if it is a one-tail test, we're going to do minus population proportion over square root of success failure over sample size. But this time we're going to have it 2, so we're going to have to subtract this sample proportion 1 from sample proportion 2 minus population proportion 1 minus population proportion 2 over square root of fooled estimate of population probability of success over fooled estimate of population probability of failure over the n is the sample size, plus same thing over success failure over sample size 2. This is, well, it looks a pretty big formula. First of all, let's see what is given in this situation and what is not given. So I'm going to have this line coming down here. So let's see what is given. Okay. So I'm going to pull out all this data. So N1 is given as a 285, and X1 is given as a 130. And also N2 is given as a 220 and X2 or R2 is given as a 124. So these are the information is given right there from the problem. Okay. But how do you find the sample proportion? This is what we know, only the sample size 1, sample size 2 is right there. But sample proportion, so we're going to find the sample proportion, which is phi hat 1 equal to x1 over n1. So we're going to actually plug it in here. So x1, what is the x1? 130 over 285. So we're going to put down here 130 over 285. And that will result approximately 0.4561. Okay, now we're going to find out the sample proportion 2, which is the same way. So this time we're going to do 124 divided by 220. So 124 divided by 220, 124 divided by 220, and it will approximately result into 0.5636. So we have this difference. Well, we can find the difference now easily. Then what else? Well, this one is going to be 0 because you already assume this is going to be 0. So this is gone. Now this one, fooled estimate of the population probability of success. That is the one we have to find. So we have, this one has a little formula here to work it out. Fooled estimate of the probability population probability of success is equal to, we add x1 plus x2 over n1 plus n2. We just add both of them and just substitute. All the information is here, just we take it from this, so we just substitute it. If we substitute 130 plus 124 over 285 plus 220. Again, it's coming from just right here. All the information is just going down here, down there. Okay. Now, pooled estimate of probability of success is equal to approximately is going to be 0.503. And the failure is going to be 1 minus 0.503 is going to give us 0.497. So we should leave at least 4 decimal places. Okay, let's actually verify the calculator if this calculation is okay, makes sense. So I'm going to actually check out this one, and so n over d 130 plus 124 over 285 plus 220. If you use a different calculator, make sure you need a parentheses, enter. So of course this is a fraction, we can do a fraction of decimal. Yeah, so we round up to 4 decimal places is going to give you 30 instead of 29 because this is bigger. So yeah, that is correct. And the failure is always 1 minus the success. So that is how we find the failure. Now we have everything ready. We have everything ready. All we just plug it in. So it's going to come down here, and this one is going to come here, and as you'll see, this one is going to be here, and that is going to be here, and so is this, so is that. And of course, sample size 1, sample size 2. So we're going to substitute everything here. So I can just substitute everything here. So sample proportion is going to be 0.4561 minus 0.5636 over square root of. Now notice that this is a pooled success. Full estimate of the probability of success is 0.503. 0.503 times the failure, 0.497, over the sample size n1, which is, in this case, we have 285 plus, we want to make sure that this square root stress all the way down, the denominator also belongs to this square root, plus same thing, 0.503 times 0.497 over sample size 2, in this case is 220. Very nice. So that will approximately is going to be negative 2.40. So I don't need those anymore. Well, let's take a look here. Is that what we're supposed to have? I'm going to use the calculator again. Let me see. This makes sense here. So I'm going to have this n over d. So 0.4561. This is 0.4561 minus 0.5636, and go downstairs. And big square root, second x squared, and we need a fraction n over d. So 0.503 times, you need a parentheses, you don't need a parentheses, doesn't really matter, this calculator is fraction friendly, times 0.497. Again, if this is a 4 decimal comes up, we use 4 decimal places, going down to 85 to the right side, plus 0.503, same thing, n over d. Of course, I missed something on the top. I have to write that down, 220, and I go to the up, and because that one is missing, so times 0.497. Done. Enter. So that is absolutely what I have here actually, negative 2.395. Notice that this is z-test. Our z-table doesn't have more than 2 decimal places, so we must round to, by default, we must round to 2 decimal places. So it's going to be negative 2.40. Again, we can just go to the mode and go float and go to number 2, enter, clear, enter. That gives negative 2.40. Very nice. So that is the z statistics we have here. Now next thing, we're going to work it out. We're going to find the phi value. Okay, we're going to find the phi value. Let's take a look. How do we find the phi value? So phi value is going to be, we're going to go to the z table at negative 2.40. So let's go with the z table. Here is the z table. So z table is, different looking table as you see, but we have negative 2.40. So as you see, negative 2.40. I can actually do it here, right here. Negative 2.4, and that's a 0. Here you go, that's a 0. So that's basically what we supposed to have. That is the phi value. That is the phi value we have. Again, if is z value is negative 2.49, we would come down here, and that's where we're going to get our phi value. And also I want to make sure that because this is a left tail, so this z table will only give the area on the left tail. If it is the right tail, we have to go to the opposite table to get the area. If it is two tail, we just go to the left one and multiply by 2. So any scenario, you can find the phi value. So our phi value is, we found our phi value is 0.0082. That's the phi value. So now it's time to come up with a decision. So how do you decide? So well, I want to make sure that we understand this one here very clearly. So that's the line, and this point here is, which is a phi, and that is going to be the alpha. So phi is 0.0082 and alpha is 0.05. Again, it was 5% significant level. So I want to make sure we understand that that is the 5%. 5% significant level is 0.05. That's the alpha. That's the threshold. We have to work it out. So if we remember a little bit of a definition, if phi value is greater than alpha, we do not reject. But if phi value is less than alpha, we do reject. So what is the conclusion? I mean decision. Look at this. This phi value is way less than the alpha. Since phi value is less than alpha, so I'm going to write this down here actually. Since phi value is less than alpha, we reject null hypothesis. Now I want to make sure that we understand much better than this actually. Here with, I'm going to draw a bell curve here. I'm going to draw a bell curve. So that's the z-score line. That's the z-score line, and okay, and right below is going to be my mean, and this z-score tells you 2.4 standard deviation below the mean. That's the location of the z-score. So it's going to be 1, 2, and this is 2.4 maybe here. So that's what I'm going to put down here, negative 2.40. And obviously this is going to be the critical region, or in this case is going to be phi value, probability value. So phi value is, and fall into this, and this is basically less than 1%, and this is 5%. So we have a freedom of 5%. This is 1%. So it's way outside. It's like outlier actually. So we are not, so it's basically is falling outside. So we reject the null hypothesis. In other words, we do not keep the null hypothesis. So we reject the null hypothesis. So conclusion is going to be the very standard straightforward conclusion we can write down here. So the conclusion at 5% significant level, so this is basically 0.05. So we can say at 5% significant level, data does, because it's outside or this is smaller, does provide sufficient evidence to conclude the last sentence we write down from here. So well, let's actually take a look here. So we can just so we can come up with that. Let's write this down here. At 5% significant level, 5% significant level, data does provide sufficient evidence to, well, I'm going to actually erase this piece here. Okay, then I'm going to do the last sentence. So what is the last sentence here? This is the last sentence. To conclude that the voter turnout in New Jersey is higher than in New York. That's how we're going to write down our conclusion. This is always standard way of writing a conclusion. So yeah, that's it. that the population proportion of a border town or in New Jersey is higher than in New York. So a couple of key things here. We have to be very careful how to get the p-value. If it is left tail, we just go to the z table and we get the p-value. If it is the right tail, we have to go to the opposite table, or we subtract from 1 to find the p-value. If it is two tail, we just go to the z table and get the p-value and multiply by 2. And if p-value is less than alpha, we reject null hypothesis. If p-value is greater than alpha, we do not reject the null hypothesis. So in this case, is less than p-value is less than alpha, so we reject the null hypothesis. Is there any other key here? Let's take a look. So this is the 5-step hypothesis test. So we need the sample proportion 1, we need sample proportion 2, and we need the full estimate of the probability of success. We need a full estimate of the population probability of failure, and we just substitute everything into the formula and we finish our 2-proportion hypothesis test. So it gives you higher, lower, or not equal, all 3 situations. After going through this video, you can do any problem comes up in regards to 2-proportion z-test. Thank you.